In topic 2.4, we're going to be learning about algebraic proofs. Before we go into proofs, you need to know your properties of equality because we're going to use them to justify our steps while doing the proofs later. So some of the properties of equality that are used a lot are the addition property, subtraction property, multiplication, and division property. Basically, the addition property says that if you have an equation like a equals b, that you can add c to both sides and your equation will still stay equal. So basically, when you're solving an equation and you're adding something to both sides, you're using the addition property of equality. Subtraction property is similar, but this time you would be subtracting from both sides. For multiplication property, same thing, but now you're multiplying to both sides. And division property, you would be dividing from both sides. So it would be like if you were to have an equation, let's say x minus 3 equals 10. When you add 3 to both sides, you're doing the addition property of equality. And then you end up getting x equals 13. So there you're using the addition property. For example, if you were to have like 6x equals 12, when you divide both sides by 6, you're using the division property of equality to get your answer x equals 2. Another property that you use a lot is called the substitution property of equality. That's when if you have two things that are equal, like let's say a equals b, then you can actually replace a with b in an expression. An example when you've used this before is when you're combining like terms. So if I have like 10x plus 2x and I replace it with 12x, I'm substituting because 10x plus 2x and 12x are the same. So when you're combining like terms or simplifying, you're usually using substitution. And a property you use a lot is a distributive property. That's when you multiply whatever's on the outside times everything on the inside. So if I were to have like 6 times x minus 3, and I distribute to get 6x minus 18, I'm using my distributive property. Here we're going to state the property that's used to justify each statement. So in example 1, it says if x plus 12 equals 10, then x equals negative 2. Well, when they were solving that problem, they would have had to do minus 12 to get x equals negative 2. So since they're doing minus to both sides, that's the subtraction property. On question 2, they went from 3 times x plus 2 to 3x plus 6. To get that, they would have done 3 times x and 3 times 2, or distributed. Since they're distributing, that's the distributive property. On question 3, we went from if 5x equals 30 to x equals 6. Well, to solve that, they're multiplying 5, so the opposite would be to divide both sides by 5, and that would end up getting x equals 6. So in order to go from their hypothesis to conclusion here, they used the division property. And in problem 4, we have if 8x minus 10 plus 7 equals 12, then 8x minus 3 equals 12. Here what they did is they combined like terms. They combined negative 10 plus 7 and replaced it with negative 3. Because negative 10 plus 7 is negative 3. So since they're replacing something with what it's equal to, they're actually using the substitution property. So anytime you're combining like terms or simplifying, think of the substitution property. So you're just making what's there smaller by combining like terms or simplifying. These properties, like I said, are going to be used when we continue with solving with algebraic proofs.